Hey everyone, and welcome. So, if you're studying accounting information systems, you're basically learning the rules of the game, right? But what if I told you the entire game board has changed? Not just once, but over and over again. Today, we're going to take a tour through that whole evolution, from old school physical ledgers all the way to the cloud, to really understand how we got here, and more importantly, where you fit into all of it. When you really get down to it, the history of information systems isn't really a story about bigger, faster machines. It's actually a century-long mission to solve one big problem: friction. The goal has always been to remove the roadblocks between something happening in a business and the information about that event. To make it faster, cheaper, and way more accessible. So let's start way back at the beginning, in a time that probably feels pretty familiar from your intro accounting classes. This is the manual era, where information wasn't some abstract bunch of ones and zeros. It was a real, physical thing you could hold in your hand.
Yeah, before computers, information had actual weight and took up space. A sales order was a piece of paper that someone had to physically walk from the sales desk over to the credit department and then to the warehouse. The office was literally a factory for processing paper. And the workflow we talk about today, well, back then, it was the actual physical movement of documents from one desk to the next.
The problems they had back then sound almost ancient, but you'll see they echo a lot of the challenges we still have today. Computing wasn't something a machine did, it was a person's job title. The office intranet for moving information around was often a network of pneumatic tubes. And get this, the CIA was still using theirs to move thousands of documents a day all the way until 1989. And just like now, data integrity was a huge headache. A misfiled invoice wasn't just misplaced, it was basically a lost packet of data, completely gone from the network.
So to solve all this physical friction, we took our first huge leap into the digital world. The mainframe computer came onto the scene, and it promised to automate the unbelievable amount of manual work it took to run a business. These first machines were absolute giants. They were housed in these special, climate-controlled rooms people called glass houses. And these weren't personal computers, not even close. They were massive pieces of corporate infrastructure. Their main job was to chew through high-volume repetitive stuff like payroll or billing. Basically, their whole purpose was to be an electronic version of a clerk. But here's the thing. This created a completely new kind of problem. Every department, accounting, marketing, product services, got its own separate automated system. Sure, they were processing data way faster, but they were all doing it in total isolation from each other. This created what we now call islands of automation, where each department's data was stuck in its own separate little world. So this model, it solved one problem, but it introduced a whole new set of digital frictions. I mean, think about it. A customer changes their address. Now you have to update that information in the accounting file, and in the marketing file, and in the service file. If you miss just one, you've got conflicting, incorrect data. People were totally trapped by the data they personally controlled, and getting information to flow across the company was next to impossible. Okay, so the solution to these digital islands was a genuine revolution in how we thought about data. It was an idea that would finally let the entire organization work from one single shared set of information.
And the big breakthrough was centralization. Instead of every department having its own separate database, the database model puts all of a company's data into one common pool. And access to that pool is controlled by a special piece of software called a database management system, or a DBMS. Now suddenly, marketing, accounting, and services can all access the exact same customer data.
And the benefits? Oh, they were immediate, and they were massive. Because data is only stored once, you get rid of all that redundancy. When a customer's address changes, you update it in just one place, and that single update is instantly available to everybody. Every single user is now working with the most current, up-to-date information possible. This was really the birth of what we call the single source of truth.
Now, this incredibly powerful database concept, well, that's the foundation for the systems that run most major companies today. Enterprise Resource Planning Systems, or ERPs for short. An ERP is basically designed to manage all of a company's main processes in a totally integrated, real-time environment. The best way to think about an ERP is as the central nervous system of the entire business. It connects everything: finance, manufacturing, sales, HR, the supply chain, all into one big unified system. So when a sales order gets entered, the system automatically checks inventory, it updates accounting, and it schedules manufacturing, all using that same central pool of data. Okay, so what does all this history mean for you as a future accountant?
Well, this whole journey from paper to these huge integrated systems has completely changed the role of the accountant. Your job isn't just about recording transactions anymore, it's about helping to shape the very systems that handle them. Which brings us to the most important question of all, right? In this world of ERPs and cloud computing and real-time data, what exactly is the modern accountant's job?
So, the modern accountant really plays three absolutely critical roles in this whole ecosystem. First, as a user, you have to be able to clearly say what the system needs to do. Second, as a designer, you actually help create the blueprint for the system. And third, as an auditor, you make sure the system has the right controls to be trustworthy and secure. Let's focus on that design role for a second because it is so important. The accountant is responsible for the conceptual system. You define what the system needs to do, the business logic, the accounting rules, the internal controls. The IT professional, on the other hand, is responsible for the physical system, how it all gets done, with what technology, what code, and what hardware. It's a really critical partnership. So we've gone from physical ledgers to integrated ERPs. The next step, which is already happening, is the move toward autonomous systems, AIs that can negotiate contracts and manage supply chains all on their own. The core principles we've talked about are still the same, but the accountant's role as a designer, an auditor, and a strategic advisor for these systems has never been more important. So the real question for you is, what will you help design next?